All right, so this is part 2 to section 2.1. I was going to work out examples, but before that, show this is like an interactive visualization of the concepts I was going over in the previous video, where that the secant line, as you get closer and closer, as I had 2 points and one of the points is fixed, and in this case, A is going to take the spot of point P in the last video. And we want to find, so if I click on this box, it says tangent line. This is the line that touches the red curve at 1 point. That's the tangent line. And you'll see that they have a slope for that. Its slope is 2. And we used a limit process involving the secant line. And to do the secant line, I need 2 points. So I'd click on this for another point. And so they just kind of pick Q at a random spot. And H is the distance, the horizontal difference between the 2 points as far as the X coordinates go. Now, if I connect the 2 points, that forms this blue line. So let me move Q a little bit, see if I can move it a little bit further away. And I can move Q by changing the distance it is. So maybe it will help to show this box or triangle. Now H is 0.6. This is the difference in the X value. So the point Q is 0.6 away from point A. If I increase this distance and their Y coordinates have a difference of 1.55. So if I increase this, let's say H is 1, you'll see the blue line is less likely or does not resemble the green line as much as I increase H. And you'll see that again, H is the difference in the X coordinates. Set H to 1, so the X coordinate of Q is 2, X coordinate of A is 1. Now the idea was the closer I get H to 0, the closer the secant lines will follow the slope of the tangent line. And right now we have slope of the secant line, it's 1.98 in green. Secant line right now is 2.98. And if you notice, it's the difference in the Y coordinates divided by the difference in the X coordinates. The difference is 1. So if I decrease it, well, if H is 0, then essentially I hit the exactly the tangent line. But no, now I made H 0.1, and you see that the slope of the secant line is 2.08, getting closer to the slope of the tangent line, 1.98. And you see the difference in the Y coordinates is 0.21, difference in the X coordinates is 0.1. So H is the difference in the X coordinates of the points. The closer I get H to the point that I'm trying to find for the tangent line, the closer it's going to mirror that for the slopes. Again, so if like H is 1.3, so I have the tangent line is the green line, the secant line is the blue line. If I shrink H closer and closer to 0, you see point Q is approaching point A, and in consequence, the blue line is getting closer and closer to mirroring that of the green line. So this is just an interactive display, just going over that concept from the last video. So now I'm going to go into some actual examples. This is where I left off. So find the slope of the tangent line for the given function at the given point. So we have two examples. I'm going to do number 9, number 8. And I would have to recall, so the slope of the tangent line, which I say MTAN, so M for slope and then subscript TAN for tangent, is equal to the limit h goes to 0, and it's f of x plus h minus, sorry, I used the letter C instead of x. All right, so this is the definition I'm going to be using. So C plus H minus f of C, where C is going to be a fixed x value. In this case, C is going to be -1 for number 9. So it's C plus H minus f of C, all that divided by H. Note that in the textbook, instead of using H, they use the following symbol, and the symbol is delta x. So delta x. Delta is usually the symbol that they use for change. So the textbook might write it as the slope of the tangent line is limit delta x goes to 0. So if the change in x goes to 0, then it's f of C plus delta x minus f of C over H. All right, or sorry, over delta x, not H. All right, that's what they use in the textbook. I'm just using H instead in place of this change in x. And that's just a choice as far as when I work out the problem. It's, I guess, less annoying to just write it as H instead of delta x. So I'm going to be using H in that place. All right, so this is what I need to find. That's going to be slope of the tangent line. So for number 9, the point they give us is -1, 8. In this case, the x-coordinate that I'm fixed at, in which I'm finding the slope of the tangent line, is going to be -1, and that's what C is. It's going to be this fixed value. C is -1. That means the y-coordinate 8, the y-coordinate you can write as f of -1 equals to 8. So when you plug in -1, you can check that you get, or sorry, equals 8. You get 8. So that's given to us. Now, if I'm going to use the definition, and again, I'm using H instead of delta x. So in this case, C is -1. So this will be the limit. H goes to 0. And f of -1 plus H. So I'm just plugging in -1 in for C, minus f of -1 divided by H. Well, we already know that we have 8. All right, so that's what this is. So this is the limit. h goes to 0, and it's f of negative 1 plus h minus 8, since that f of negative 1 is 8. That's given to us by the point over h. So now I need to find what f of negative 1 plus h is. And I'll use a different color. So this means we're inputting negative 1 plus h into the function. Our function has an equation of 3 minus 5x. So this is going to be 3 minus 5, and in the spot for x, I put in negative 1 plus h. And again, I just plugged in. So we have inputs x in this case. So wherever x is in the equation, that's where I'm plugging in negative 1 plus h. All right, so then I distribute the negative 5. So that's going to make this 3 plus 5, and then minus negative 5h. And then 3 plus 5 is 8. So this is 8 minus 5h. Now that's what all of this is. So we're going to have the limit. H goes to 0, and instead of negative 1 plus h now, or f of negative 1 plus h, I found that in green, and plugging in negative 1 plus h into the function, and the output was 8 minus 5h. And then, so that's that part, and then I still have the minus 8. All of that divided by h. And we can cancel out 8 with minus 8. So that's going to give us limit h goes to 0, negative 5h divided by h. Well, I can do h divided by h. So we're left with negative 5. Now there's no h involved, so it doesn't matter what it's going to be approaching to. The result's negative 5. And then this is the slope of the tangent line. At the point negative 1 comma 8. All right, so I just used the definition. Slope of the tangent line is this limit. H goes to 0, f of c plus h minus f of c divided by h. C is the x-coordinate of the fixed point in question. In this case, c is negative 1. That means f of c is f of negative 1. And f of negative 1 is the y-coordinate of that fixed point, and it's got a y-coordinate of 8. So that's given to us. We don't have to necessarily plug negative 1 into the function, but if you did, you would get, 8. You would get 8, because you'd have 3 minus 5 times negative 1, which will be equal to 8. All right, so then I just did this as scratch work. Off to the side, I found this f of negative 1 plus h in green. And that's just putting in for your input negative 1 plus h, plugging it in, and it simplifies to 8 minus 5h. All right, that's what the green is, and then that way it can cancel out the 8's. And then h divided by h, those cancel out. I'm left with -5. And so there's nothing to plug in, so I'm just left with that -5. So the slope of the tangent line at the point -1, 8 is -5. All right, so that's how you do these kind of problems. The next one. So same idea, it's just a different function, 2x squared minus 3 in a different point. And then the point that we're trying to find for the tangent line, 2, 5. So I'll write the definition, so slope of the tangent line. The limit h goes to 0, f of c plus h minus f of c over h. In this case, c is 2. So f of c is f of 2. So this will be limit h goes to 0, plugging in 2 in for c. That's f of 2 plus h minus f of 2 divided by h. They give us the y-coordinate of the point. So f of 2 is equal to 5. So this would be minus 5 divided by h. And then I'm going to do the f of 2 plus h off to the side. So anywhere I plug in, so where an x is, I plug in 2 plus h. So this is equal to 2 times 2 plus h in parentheses squared. And then minus 3. So from algebra class, if you have a binomial and it's like a plus b squared, that turns into a squared plus 2ab plus b squared. So in this case, this is going to equal 2 times parentheses, so 2 squared is 4, plus 2 times h, which will be plus 4h, and then plus h squared, and then minus 3. All right, so that's just using that formula, or you could write it as 2 plus h times 2 plus h. So that's what this became. And now I'm going to distribute 2. So 2 times 4, that's going to be 8. 2 times 4h plus 8h, and then plus 2h squared. And then I have the minus 3. I can combine 8 minus 3, that's 5. And that's the furthest I can go with the simplification. All right, so I'm going to circle this. 5 plus 8h plus 2h squared. That's what that portion became. Okay, so in green, that was 5 plus 8h plus 2h squared. And then I have the minus 5. All right, so now I can cancel out 5 with minus 5. That leaves me with 8h plus 2h squared divided by h. Now h, all the terms have h, and I can divide out h. So if I factored out h and divided the common factor of h, that's going to cancel out this with this one, and then an h from 2h squared to make that just 2h. So now I just have 8 plus 2h. All right, and I can plug in 0 now for h. All right, so that's just 0. So that's 8 plus 0 is 8. And so 8 should be the slope of the tangent line. And it was the point 2 comma 5. Okay, so that's going to be the answer. All right, I'm going to make a comment that I didn't mention earlier, but a comment. We do all this simplification and then plug 0 in for h. And that's because you would have 0 in the denominator at the beginning. So let me write down what we had in the beginning. So I plugged in 0. Essentially, it's because if I have to limit h goes to 0, f of c plus h minus f of c. If I plugged in 0 for h, that's f of c plus 0 minus f of c divided by 0. And that's going to give me 0 over 0. All right, so that's an indeterminate form for a limit. All right, so that's why we don't plug 0 in for h in the beginning of the problem. And we do all this algebra to simplify it to where we can plug in 0 in for h. All right, so those two examples are finding the slope of the tangent line. These next couple examples are going to be finding the derivative. And it's pretty similar, but the end result is going to be a function. So for the following, find the derivative. And again, they use f prime of x is what it's called. So number 17 in the textbook, or function f of x, is equal to negative 5x. Now notice there's no point that we're given in this question. It's just the function. So the end result is going to be a function. Now the function could be a single value, but it's called a constant function if that were the case. But you'll see in this example that I do get a single value, but for the next problem, it won't be like that. You get a different kind of function. So we'd have to apply the definition of derivative, and the definition of derivative is pretty much the same as the definition I was using in the previous example. Instead of using c, we're using x. So the definition of derivative is this: limit h goes to 0, f of x plus h minus f of x divided by h, and x is going to be any value in general, whereas c is a particular value that we're focusing on. But in this case, we don't have a particular value we're focusing on. We're doing it for any x. All right, so f prime of x equals limit h goes to 0, f of x plus h minus f of x divided by h. All right, that's what we're going to apply. Now, I'm going to do this off to the side, so I'll use green. If I wanted to find f of x plus h, that's plugging in my input is x plus h into the function. The function's -5 times x. So instead of -5 times x, it'll be -5 times parentheses x plus h. So I'll make sure to put the parentheses because that whole thing's being in the spot for x, which in this case I can distribute the -5, which will give me -5x minus 5h. All right, that result is what that is in the formula. Limit h goes to 0, and instead of f of x plus h, which I found in green, that's -5x minus 5h. And f of x, well, what is f of x? F of x is -5x. So it's going to be minus, because of the minus in the formula, but then there's a minus with the 5x. So it's going to be minus times minus 5x. You got to be careful with the minus signs. And then divided by h. All right, and so this two negatives make positive, so really this is like plus 5x, but since I have a -5x, I can cancel that out with the plus 5x, and that gives me -5h divided by h. And then the h's divide out, so you get -5. In which case, whatever h you plug in, there's no h in the formula at this point, it's just -5, so the limit is going to be -5. And this is the derivative, so we'd say f prime of x equals -5, and it is a single value, but this is a function. So really, this is a function. It's called the constant function. It's always -5. So that is what the derivative is. And it did come out to be a particular value, -5, but the difference is that this is a function. Whereas earlier, when we're finding the slope, like here we got 8, that value is the actual just single value of 8 for the slope. Whereas we get a function when we find the derivative. And that distinction is important. So a constant function is just where you plug in any input, you get the same output of this case, it's -5. And so really that's a whole, if you were to graph it, now this is just an aside. So if I have my X and Y axes and I were to plot -5, somewhere, it'd be a horizontal line that goes like this. That would be the graph of the derivative function. All right, that's what the actual function is graphed. All right, so that's just an aside, just to point out that when they find the derivative, it's going to be a function versus just a single value. In this case, it's happened to be -5, so it was a little, I don't know if deceiving is the right word, but it might throw you off. This next one's going to be same premise, but it's going to be number 21. And our function in this case is x squared plus x minus 3. And we're going to find the derivative of this function. It's f prime of x. So I'll just write the definition. F prime of x is equal to the limit h goes to 0, and it's f of x plus h minus f of x divided by h. And like before, I'm going to just break it down piece by piece. I'll first find the f of x plus h piece to however amount I can simplify that down. So f of x plus h, wherever I see x in the function, that I'm putting in x plus h. So instead of x squared, it's going to be x plus h squared instead of plus x. That's going to be plus x plus h, and then minus 3. The parentheses isn't necessary. It's just I like to put parentheses anytime I plug in the input for the particular variable, and that's in this inferred spot. Now x plus h squared, that turns into x squared plus 2xh plus h squared, right? Because from algebra, if you have a plus b binomial squared, that's a squared plus 2ab plus b squared. It's just different letters in this case. Instead of a, it's x. Instead of b, it's h. Or you could do x plus h times x plus h and FOIL it out, and it comes out to be this, x squared plus 2x h plus h squared. All right, so I still have the plus x plus h and then minus 3. And there's no like term, so that's actually what it is. All right, because x squared is a different term than just x, 2xh is a different term than just h, and h squared is a different term than h. So all of that so h goes to 0 instead of f of x plus h. I'm going to write everything you see down there in green. So it's going to be a lot of stuff on the numerator. So x squared plus 2xh plus h squared plus x plus h, and then minus 3. All right, that's just the f of x plus h portion. So then I still have the rest of its minus f of x. Now here I have a minus sign, so I'm going to put minus sign, and now I plug in f of x is all of this. So I'm going to put all that in parentheses, so it'd be minus and then x squared plus x and then minus 3. All of this is divided by h. All right, so this green portion, that's f of x plus h. When I simplified it or just expanded it out, so this is f of x plus h, and then this is f of x, just based on the formula. So because there's this minus sign, I would distribute the minus sign. So it goes to minus x squared, then minus x, and then minus times minus 3 makes positive 3. So because that's a minus x squared, I can cancel out with the positive x squared. Because this is going to be a minus x, I can cancel with the positive x. And then a minus times minus makes positive, so really it's positive 3. I can cancel that out with minus 3. All right, so what I'm left with is 2xh plus h squared plus h. Again, so that's 2xh plus h squared plus h. All of that's divided by h. All of these have the variable h, and h could be factored out. And when it's factored out, you can divide out the h from all 3 terms and on the bottom. So I can cancel out h from those, and then cancel it out from h squared. Now you got to be careful, because if I cancel out from just plus h, there's really a 1 right there. So maybe I will work it all the way out. So what I'm saying is, if I factor out h up top, that 2xh becomes just 2x, and then h squared becomes just h, and then you factor out h from h divided by h is 1, so we plus 1, and then all of that's divided by h. So I was kind of not writing it all the way out like this, but people seem to get it messed up by, just because the h and h divide out, they just don't think there's anything left over. It's 1 is what's left over, so really those divide out. That means I have a 1. So that's usually where people make a mistake. So make sure that you have this as to include 1. All right, and on the right side, that's what it would be if I worked it all the way through. So I'm left with 2x plus h plus 1. And again, so that's the whole thing, 2x plus h plus 1. And now I plug in 0. If I plug in 0, you'll get 2x plus 0 plus 1, which will be 2x plus 1. So notice I still have x involved, so I have a function, and this function is a line. So the derivative is 2x plus 1. All right, again, it's a function. All right, and I'll do another one, and this next one is going to be number 25 out of the textbook. right, so our function is going to be 1 divided by x minus 1. All right, so I'm going to be finding the derivative. All right, and again, I just always write the definition. So it's limit h goes to 0, 1 over, oh, sorry, f of x plus h minus f of x divided by h. Now f of x plus h, that's equal to 1 over, and instead of x, it'll be x plus h minus 1. And again, you can just ignore the parentheses and just write it without the parentheses. So there's really not much simplifying I can do with that. So that's what I'm going to write in that spot. So instead of f of x plus h, it's 1 over x plus h minus 1. All right, and the other one, f of x, well, f of x is 1 over x minus 1. And all of that's divided by h. All right, so this is a little bit more complicated one because we want to combine these into one fraction. So I'll make that comment. So to make this one fraction, I need to have a common denominator. And the common denominator is going to be x minus 1 times. So the least common denominator is the combination of the two denominators, and that's going to be x minus 1 times x plus h minus 1. That's what the LCD is. And if I want to change these, so I'll rewrite it. So I have 1 over x plus h minus 1, and then minus 1 over x minus 1. So if I want to change the x plus h minus 1 so it has the same denominator, it's missing the x minus 1 portion. So what I'm going to do is I need to multiply the first fraction I'm going to multiply top and bottom by x minus 1. All right, that way it has x minus 1 and the x plus h minus 1. The second fraction has the x minus 1. It's missing the other part, x plus h minus 1. So that's what I multiply the second fraction top and bottom by. Now, mind you, all of this is being divided by h. I'm just focusing on the top part to make that one fraction. All right, so what I'll have, limit h goes to 0. So they have the x minus 1 times x plus h minus 1 denominators. So I'm going to go ahead and make it one fraction. And so I have x minus 1 times 1 is x minus 1. And then I have minus 1 times the x plus h minus 1. All of that over the common denominator, x minus 1, x plus h minus 1. And again, everything's being divided by h. All right, so what I'll do next is distribute the minus 1. I'm just trying to simplify the top part. And what is that going to do? So I have minus 1 times x, which makes minus x. But I have x over here, so I can cancel out x with the minus x. And then I'll have minus h, and then a minus 1 times a minus 1 is positive 1. But I have a minus 1 over here. So I can cancel out 1, or minus 1 was technically that turned into 1 because of the other negative. So that leaves me with just negative h. That leaves me with just negative h, and then x minus 1, x plus h minus 1, all of that's divided by h. Now the h's do divide out. So I can cancel those. Now I just have minus 1 up top. And then on the bottom, so the h on the very, very bottom, I guess, it canceled out with the h on the very, very top. So this will be x minus 1, x plus h minus 1. Now I would go ahead and plug in 0 for h, since I'm not going to have any indeterminate forms. So after I plug it in, so plugging in 0 for h, that's going to make minus 1 divided by x minus 1 times, instead of x plus h minus 1, it's x plus 0 minus 1. Which is x minus 1 times x minus 1. So that's negative 1 over x minus 1 squared. Now you could distribute that or FOIL it out. It's not, you don't have to. So this is really what it turns into in its most simplified form. F prime of x is equal to negative 1 over x minus 1 squared. All right, so that problem was a little bit more complicated, but the idea is still the same. In this case, f of x plus h turned into 1 over x plus h minus 1, that's what's in green, and then I have minus f of x. Well, f of x is 1 over x minus 1, and we still have the divided by h. Now the thing is, I want to combine these two fractions into one fraction. So the common denominator I need is x minus 1 times x plus h minus 1, basically multiplying one denominator by the other one. The first fraction, 1 over x plus h minus 1, is missing the x minus 1. So that's why I'm multiplying that one top and bottom by x minus 1. The second fraction is missing the other denominator, x plus h minus 1. So that's what I multiply top and bottom by. After I do that, they're going to have that x minus 1 times x plus h, and then minus 1 as the denominator. So I'll combine into one fraction. So I have x minus 1, then minus 1 times this whole thing in parentheses, x plus h minus 1. So after you distributed the minus 1, that's where I can cancel stuff. And after you cancel stuff, you're left with negative h up top. And the negative h at the very top can divide out with the negative 8, or with the h at the very bottom. That left me with negative 1 over x minus 1 times x plus h minus 1, and I can go ahead and plug 0 in for h. That's not going to give me any problems. It'll give me now the result of that, negative 1 over x minus 1 squared. And you could multiply that through if you want. but I like to keep things in the most simple form, and this is the most simple form, is to leave it as x minus 1 squared. All right, so that's the answer. The derivative of the function is negative 1 over x minus 1 squared. All right, so I figured I wanted to do one that was a little bit more complicated, but we're still using the same general idea, is to use that limit definition for derivative. So we know the derivative of the function. If you plug in the x coordinate, it gives you the slope of the tangent line at that particular point. This next example is going to be finding the equation of the tangent line itself. So for the following, find the equation of the tangent line itself. That's for the given, to the tangent line itself for the given point. At the given and the given function. This is number 29. The given function f of x is equal to x squared plus 3. And the given point is negative 1 comma 4. So we know we can get the slope of the tangent line. So a couple of points. First comment, we can get the slope of the tangent line you could either find the derivative and plug in negative 1, or you could use the definition from earlier by doing slope of the tangent line, limit h goes to 0, of f of c plus h minus f of c over h, and in this case, c is negative 1. F of c is f of negative 1, which equals 4, the y coordinate of the point. All right, so we can get the slope of the tangent line by doing that limit. The next thing we need to do is actually find the equation, so we can then determine the equation for the tangent line. And we can determine that equation either in two ways. You could write it as point slope form, and that's y minus y1 equals m times x minus x1. And that's the quickest answer, is the point slope form, or you can write it in slope-intercept form. Y equals mx plus b. Now point slope form, so you found m from step 1. So this is m is from step 1. Now you could use the point that you're given in the question, negative 1 comma 4, to plug in for x1 and y1. And then basically you'll have your equation after that. So that's the easiest way, just put in point slope form. That's how I'm going to do it. And then I'll write down what the answer would be in the slope-intercept form. All right, so that's the common to the process. We find the slope of the tangent line by doing that limit that we've been doing in the previous examples. And then we just find the equation for the line itself. And we could write it in either point slope form or slope-intercept form. Point slope form is the quickest, so that's the one I'm going to do. You could rewrite point slope form into slope-intercept form if you're wanting it to look like that. So I will write it in slope-intercept form also as far as what it would look like. All right, so our function is x squared plus 3. And again, the point that was given is -1, 4. So C is the x-coordinate of that point. And then f of -1 is for the y-coordinate of the point. So I can, first thing is determine the slope. So the slope of tangent line, excuse me. All right, so resuming where I left off. So we have C is -1, f of -1 is 4. So then finding the slope of the tangent line at first using the definition. So I'm just writing the definition. So that's f of C plus h minus f of C over h. And then in this case, C is -1. So that's limit h goes to 0, and it's f of -1 plus h, and then minus f of -1. All of that divided by h, and we know f of -1 is 4. So that's going to be f of -1 plus h minus 4 over h. And I'm going to find the f of -1 plus h sort of off to the side like I've been doing. So f of -1 plus h. My input's -1 plus h, and I just plug -1 plus h in for x into the equation. So x squared, it's going to be -1 plus h squared. And then it was plus 3. All right, so -1 plus h squared, you can expand that out, and that's going to be 1 minus 2h plus h squared, and then I have the plus 3. So if you expand -1 plus h out, it should turn into 1 minus 2h plus h squared. All right, so I combine 1 and 3 to make 4. All right, so that's pretty much the furthest I can go as far as the expansion goes, and that's what I've plugged in for f of -1 plus h. This will be the limit. H goes to 0, and then I'll put what I have circled in green. Okay, so that's what f of -1 plus h is, and then minus 4. All of that divided by h. Now I can cancel out 4 with minus 4. All right, so I have -2h plus h squared divided by h. And I can divide out h from all the terms. It's a common factor. So if I divide out h from everything, so that's going to make this -2. That'll make this just h. And then that h in the denominator divides out. So I'm left with limit h goes to 0, -2 plus h. So now I could plug in 0 for h. right, so I have -2. And this is the slope of the tangent line. All right, so I have half the battles done. I just need to find the equation of the tangent line itself. So I'm going to use point slope form. That's y minus y1 equals m times x minus x1. Well, I know the slope is -2. So that's what m is. Y minus y1 equals -2 times x minus x1. All right, and then I just plug in my point that you're given in the question for the coordinates x1, y1. Now again, the point that we're given is -1, 4. So I use x1, y1. So that'll be y minus 4 equal to -2 times, and then x minus -1 turns into x plus 1. All right, and that is the equation of the tangent line. Right? That's the point slope form of it. All right, that's what they want, the equation of the tangent line. So that's going to be the answer. If you did re-put it in slope-intercept form, it would be y equals -2x plus 2. So either one of these is acceptable. It's just this point slope-intercept form is just a little bit more steps. All right, and that's where I'll stop it for this. This is the end of section 2.1.